Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my last video, I was actually teaching matter in our surroundings, which is actually the first chapter of 9th standard science subject. So in that, I have already taught you all the topics which are there in this particular chapter. So in this particular video, I'll be explaining the exercise questions which are there in this particular first chapter. So coming to the first question in this exercises, they have given two temperatures and you have to convert that particular temperatures which are there in Kelvin to degree Celsius. So if you refer my previous video, there I have explained you that at 0 degree Celsius, if you want to convert this 0 degree Celsius into Kelvin, it will always be 273.15 Kelvin. So you should remember, if temperature is 0 degree Celsius, in Kelvin scale, it will be 273.15 Kelvin. Now, if you increase this 0 degree Celsius to 1 degree Celsius, here also you should increase this by one number. That is 274.15 Kelvin. So similarly, now they have given 293 Kelvin. So now if it is 293 Kelvin in degree Celsius, approximately it will be 20 degree Celsius. Answer for A question in this particular first question, that is for 293 Kelvin, the temperature in degree Celsius will be 20 degree Celsius. So now coming to the B question in this particular first question in the same exercise, there they have given 470 Kelvin. So now you can just subtract 273 from this particular 470. So now if you want to convert 0 degree Celsius to Kelvin, it will be 273.15 Kelvin. So that means 273.15 units you should actually add to 0 to get the same temperature in Kelvin. So now you have temperature in the scale of Kelvin itself. So now you should actually subtract this with 273.15, or approximately you can consider this as 273. So 470 minus 273 will be 197. So 470 Kelvin is nothing but 197 degrees Celsius. So the answer for this particular B question in first question will be 197 degree Celsius. Coming to the second question in this particular exercise, here you should actually convert the temperature which is given in degree Celsius to Kelvin. So here it is simple. You should just add 273.15 Kelvin to the existing degree Celsius. So you will get that particular temperature in Kelvin scale. So coming to the first question in this particular second question, that is A question, there they have given 25 degrees Celsius. So you can straight away add 25 plus 273.15, or simply you can add 273 approximately. So 273 plus 25 will be 298 Kelvin. So the answer for this A question will be 298 Kelvin. Similarly, coming to the B question in this particular second question, there they have given 373 degrees Celsius. Now you can just add 373 and 273. So when you add 373 and 273, you will be getting 3 plus 3 6, 7 plus 7 is 14, 1 carry. So 3 plus 2 plus 1 will be 6. 646 Kelvin is the answer for this particular B question. So the answer for this B question will be 646 Kelvin. So answer for A question will be 298 Kelvin. Answer for B question will be 646 Kelvin. Coming to the third question in this particular exercise, you have two sub questions in this particular third question. So the first question is A question. There they have asked, naphthalene balls will actually disappear with time. Why? Because naphthalene balls will undergo a phenomena called sublimation. So if you want explanation for this sublimation, you can refer my previous video where I have explained what is sublimation, where the solid directly converts into vapors without converting into a liquid state. So this kind of process is known as sublimation, and I have explained this in my previous videos. So this particular naphthalene balls which are in solid state will be evaporated into vapors directly from solid to gaseous state. Hence, this particular naphthalene balls over a period of time they get disappear. That means the molecules which are there in that particular naphthalene balls will be evaporated and vaporized into gaseous state slowly over a period of time. So this is the answer for A question. Coming to the B question, even several meters away if you are sitting, still you can actually smell that particular naphthalene balls. Why? Because the molecules or the particles from that particular naphthalene balls which get vaporized will be traveling around the atmosphere in that particular room. So even if you are actually sitting certain meters away from that particular naphthalene balls, whenever those particles which got vaporized into the atmosphere will travel through the atmosphere until your nose, and you can smell that particular naphthalene balls. So the process which is happening here to naphthalene balls is known as sublimation, and even if you are sitting away from it, the vapors which are actually got vaporized from that particular naphthalene balls are hitting your nose, hence you can actually smell that particular naphthalene balls. So coming to the fourth question in this particular exercise, here they have given three objects. One is sugar, second one is water, and the third is oxygen. So based on the interparticular force of these particular objects, you should actually arrange this in an increasing order. So which particular object among these three will have less force between the particles and which will be having highest? So you should actually arrange that in an increasing order. The lowest force will be for oxygen particles, because oxygen is in gaseous state and we know that gaseous particles are very loosely bound with each other. Hence, this oxygen molecules will be having less amount of force. Oxygen particles will be having less amount of force in between them. So next will be water, because water is in liquid state, hence particles will be little bit tightly bound compared to gaseous state. Hence, water will come next. Next will be sugar, because sugar crystals are solid in nature. Particles are very much tightly bound in this particular sugars. Hence, the force between particles inside sugar crystals will be more compared to water and oxygen. So this is the increasing order of particle force in oxygen, water and sugar. Coming to the fifth question in this particular exercise, what will be the state of water at these particular temperatures? So the first temperature which they have given here is 25 degrees Celsius. So at 25 degrees Celsius, water will be in liquid state. That is, water will be just water. So at 0 degrees Celsius, that is for B question in this particular fifth question, they have given 0 degrees Celsius. So at 0 degrees Celsius, water will be solid in nature, that is actually ice. So in bracket I am writing ice. So water will be ice at 0 degrees Celsius. And coming to the C question in this particular fifth question, they have given 100 degrees Celsius. So at 100 degrees Celsius, water starts evaporating. That means 100 degrees Celsius is the boiling point of water, 0 degrees Celsius is the melting point of water. So melting point and boiling point also I have explained in the previous videos, which is related to matter in our surroundings. So you can refer those videos. So melting point is that particular temperature at which any kind of liquid will be converted into solid, and boiling point is that particular temperature range at which liquids will be converted into gaseous state. So here 100 degrees Celsius for water is boiling point of water. Hence at 100 degrees Celsius, water will get evaporated. So that means water will be turned into gaseous molecules. So the answer for A question will be liquid state, answer for B question will be solid state, and answer for C question will be gaseous state. So water will be in liquid state at 25 degrees Celsius, solid state at 0 degrees Celsius, gaseous state at 100 degrees Celsius. Coming to the sixth question in this particular exercise, there they have given two questions. So the first question, that is A question in this particular sixth question, they have given water at room temperature is a liquid. You should actually give two reasons why water at room temperature is liquid. Because room temperature is always known as 25 degrees Celsius. So if there is a temperature anywhere between 25 degrees Celsius to 30 degrees Celsius, this particular temperature range can be known as room temperature. So we all know that point number 1, at 0 degrees Celsius, water will be converted into solid. Point number 2, at 100 degrees Celsius, water will be converted into gaseous state. So at 100 degrees Celsius, water will be in gaseous state. So that means 25 to 30 degrees Celsius is in between 0 degrees Celsius and 100 degrees Celsius. That means it is below boiling point and it is above melting point. That means this particular water at 25 degrees Celsius to 30 degrees Celsius, it will be in liquid state. So these two reasons you can actually give, because room temperature is greater than melting point, hence water will be in liquid state. And you can give this second point as well, where the temperature range is below boiling point, hence water will be in liquid state. So the temperature, that is the room temperature 25 degrees Celsius to 30 degrees Celsius, is in between melting point and boiling point. Hence at this particular temperature water will be at liquid state. So this you can give as a reason why water at room temperature is in liquid state. Coming to the B question in this particular sixth question, there they have asked an iron almirah is a solid at room temperature. Why? Because room temperature is the temperature range between 25 degrees Celsius to 30 degrees Celsius. So you can assume 25 degrees Celsius as room temperature. But the melting point of iron is actually 1538 degrees Celsius. So that means room temperature is never 1538 degrees Celsius. It is much more lesser than 1538 degrees Celsius. That is, room temperature is 25 degrees Celsius, which is less than 1538 degrees Celsius. Very much lesser than 1538 degrees Celsius. Hence, iron almirah in your room temperature, it will always be a solid. So hence its melting point is very high. Iron almirah will be always solid at room temperature. So iron will be solid at room temperature because its melting point is very much greater than the room temperature. So coming to the seventh question in this particular exercise, there they have asked why ice is much more effective in cooling at 273 Kelvin temperature compared to water at same temperature. Ice will absorb more heat than water. So ice absorbs the external heat very quickly and converts into water. Even after absorbing heat, the temperature of ice will be at 273 Kelvin itself. But the extra heat energy which you are actually supplying to that particular ice will be in the form of latent heat, because it has more capacity to absorb heat to convert itself into water. Hence, ice acts as effective cooling material compared to water. So let me explain this by using some pictures. So let's say this is an ice cube. This particular ice cube will be having temperature 273 Kelvin. Any temperature more than 273 Kelvin in the surrounding of this particular ice, immediately this particular ice will absorb this particular heat, but the temperature of this ice will remain 273 Kelvin. But still it will be absorbing heat. Then that extra heat will be converted into water. So the ice actually uses the heat which is present in the surrounding and it will get converted into water. But as such, the solid ice will be having temperature 273 itself. That means ice will be absorbing heat and it will be converting into water. So ice will absorb this surrounding heat and it will be converting into water. So that means the heat which the ice is absorbing is to convert this particular ice into water. So that means even at 273 Kelvin, even the temperature of ice is 273 Kelvin, it has the capacity to absorb more and more heat and get converted itself into water. That means ice has more power of absorbing heat compared to water. Because water is already in liquid state, it will not get converted into any other state at 273 Kelvin. But at 273 Kelvin, ice will start absorbing heat which is slightly above 273 Kelvin, and this particular ice starts melting. So ice is actually absorbing heat, but the temperature of ice is not increasing. So this is known as latent heat. Because of this latent heat, the ice temperature will remain 273 Kelvin and it has the capacity to absorb more and more heat. So that means cooling is always defined as absorption of heat. That means in a refrigerator, if you are keeping something, so let's say this is a refrigerator. So inside refrigerator, if you are keeping some items, so those items will be cooler, but outside part of refrigerator, if you touch, that will be hot. That means the extra heat which was there in that particular objects inside refrigerator, the refrigerator is sucking out that heat from that particular objects and it is dissipating that heat into the surrounding. So hence if you touch the outer surface of refrigerator, it will be hotter. So similarly, ice will absorb the heat which is there around it. That means it absorbs the heat which has temperature slightly more than 273 Kelvin. By absorbing that particular heat, this particular ice will get converted into liquid state. but still the temperature of ice will be 273 Kelvin. Unless and until complete ice is melted into water, the temperature of ice will be 273 Kelvin itself. So that's why it will be absorbing more and more heat from the surrounding. That means it keeps its surrounding cooler because it is absorbing more and more heat. Hence, ice has more power of absorbing heat, but water at same 273 Kelvin temperature doesn't have that much amount of heat absorption, where ice has more amount of heat absorption at 273 Kelvin compared to water. So this is the explanation which I have given for this 7th question. You can write this explanation in your own words in your exams. Coming to the 8th question in this particular exercise, here they have asked, boiling water causes severe burn or steam causes severe burn. Here boiling water will be having temperature of 100 degrees Celsius. So the extra heat, even after this 100 degrees Celsius, which you are actually providing for this particular boiling water, that will be actually in the form of latent heat of vaporization. So this particular latent heat will be there in the steam. So now let's say in a container you have water. So in this water, for this water you are actually supplying a necessary amount of heat energy. When you supply necessary amount of heat energy, and if this heat energy has temperature more than 100 degrees Celsius, then this particular water starts boiling. So this particular water will start evaporating. The temperature which you are supplying to water is more than 100 degrees Celsius. But if you keep thermometer in this particular water and if you check the temperature, it will be 100 degrees Celsius itself. That means even though if you are supplying more and more heat, still the temperature of 100 degrees Celsius, the temperature of water will be 100 degrees Celsius itself. It will not be more than 100 degrees Celsius. Then where did that extra amount of heat has went? Let's suppose say you are supplying 110 degrees Celsius temperature of heat for this particular water, and this particular water is getting boiled at 110 degrees Celsius. Where did this extra 10 degrees Celsius is going? So this particular steam will be having 100 degrees Celsius temperature plus 10 degree latent heat of vaporization as well. So that means this particular steam will be having that particular 100 degrees Celsius and also the extra heat, that is the extra 10 degrees Celsius temperature will also be there along with that 100 degrees Celsius. Hence the temperature of steam is more than 100 degrees Celsius. Hence steam will be much more hotter compared to the boiling water. So let's suppose say you are supplying 110 degrees Celsius temperature of heat to this particular water. So this water will just show 100 degrees Celsius in the thermometer, but the extra 10 degrees Celsius heat will be in the form of latent heat with this vapors of water. That means water has got converted into gaseous molecules, and this particular steam or this particular gaseous molecules which has got evaporated from this water, so that particular water is boiling at 100 degrees Celsius. The extra heat which is more than 100 degrees Celsius is there in the form of latent heat with that particular steam. So that's why steam will be having the maximum amount of temperature more than 100 degrees Celsius. So that's why steam will be hotter compared to water. Coming to the 9th question, here they have given a diagram and they have given A, B, C, D, E, F. So you should actually name what is A, B, C, D, E and F. So now in this particular diagram they have given solid converting into liquid and liquid converting back to solid. So they have given two arrows like this. So this first arrow where solid is getting converted into liquid is A, and the second arrow, that is liquid converting back to solid, they have named as D. Now liquid is getting converted into gaseous state. Again this particular gaseous molecules are converting back into liquid state. So here this particular arrow is B and this particular arrow where gaseous molecules are converting back into liquid molecules is named as C. Now solid is directly getting converted into gaseous state, and this particular route way is actually named as E. Here gaseous state is converted back into solid state and this particular pathway is named as F. Now you should actually name what is A, B, C, D and F. So conversion of solid into liquid is actually known as fusion. So A is actually fusion. So converting liquid back to solid is actually known as solidification. So this particular D is actually known as solidification. So I'll write this neatly in a separate slide. So A is actually fusion, that is solid getting converted into liquid. D is actually solidification, that is liquid converting back into solids. So coming to the next step, that is liquid converting into gas, that is actually named as B. So that is vaporization. Whenever liquid converts into gaseous state, that process is known as vaporization. So here the pathway where gaseous molecules converting back to liquid is named as C. So this particular process is known as condensation. So the process of gaseous molecules converting back into liquid molecule is known as condensation. So the next pathway which they have given is E, that is solid getting converted into gaseous state directly without converting into liquid. That is actually known as sublimation. So coming to F pathway, that is gaseous state molecules converting directly to solid state without converting into liquid state. So this process is known as deposition. So answer for this F will be deposition. So A will be fusion, D will be solidification, B will be vaporization, C is condensation, E is sublimation, F is deposition. So I have given answers for all the exercise questions which are there in this particular 9th standard chapter 1. Similarly, I will be uploading more and more videos related to physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.